All right, so we've talked about graphing, we've talked about our unit circle, we've talked about all kinds of fun stuff with our trig functions. So now we're going to talk a little bit about inverse functions. So we use the unit circle or graphs to evaluate some of our trig functions, sine, cosine, and tangent, and for various different types of angles. So, but what if we are given the opposite? What if we're given the ratio and we want to find the angle? Can we do that? So let's look at question number 1 here. So what graph is shown there? What normal trig graph is shown? Sine, perfecto. So for what values of theta, so in radians, is sine of theta equal to square roots of 3 over a 2? So square roots of 3 over a 2, where is that going to be? So pi over 3, good deal. So pi over 3 and a 2 pi over a 3. Sorry, let me get that. So, so pi over 3 and 2 pi over 3. So where do you think square roots of 3 over 2 lies? So what is, if you plug square roots of 3 over 2 in your calculator, what do you get? What's the value for that? It's a decimal value, so what is it? I just don't know it off the top of my head. So what do you get when you plug square roots of 3 over a 2 in your calculator?
0.866.
How much?
0.866.
0.866. So that's where? About, I don't know. You want to say like about right here? Yeah. About right there, do you think? Okay. So these, if I were to draw a line right here, so let me try to make a straight line here. So if I were to make a straight line through that sine graph, that is it going to be multiple? Is it going to be more than just those two? Pi over 3 and 2 pi over 3? That's a terrible straight line, I'm sorry. What happens with sine? What does it do? It oscillates, right? Oscillates. So it's going to repeat this every how much? 2 pi. So it's going to be into infinity, right? So in both directions, but it'll repeat every 2 pi units, right? Okay. So what about the values of theta where sine of theta is equal to a negative 1/2? Now that's going to be a little bit better for me. So if I were to draw a negative 1/2, so where's that? About right here? So now that's a better straight line, Miss A, right? That's completely better straight line. So how many spots will I have? Will sine be equal to a negative 1/2? So what do you think? And think about your unit circle as well. So what are my positive values here? Aren't they they're so so sine of theta is equal to a negative 1/2 at what radian values here? So 7 pi over 6. All right, good deal. So 7 pi over 6. What else? 11 pi over 6. And then let's go the opposite way. So let's look at the negative because I did draw that straight line and it touches 2 more places over here. So what are my other spots? What is that one here? So what, a negative, if I were open in the negative direction on your unit circle, right? So it would be a what? Negative pi over 6? Yeah. And then what else? Perfect. So negative 5 pi over 6. Okay. Is that fair? Do you feel okay about that? Okay. So is sine a one-to-one function? So what is one-to-one? What does that mean? Okay, so it passes the horizontal line test, right? So 1 to 1, it passes the horizontal and my vertical line test. So vertical line test means that it's a function, and a horizontal line test means that it would be 1 to 1. So for one y value, there is one x value. Yes? So is that true? So for one y value, is there one x value? So passes the vertical line test. So that's what the vertical line test is, right? So is that true? Does it pass that? So one y value for every x, does it pass that one? So it's a function, right? So that is true. So this one is true. So this one is a yes. Okay, but it also has to pass for one x value. There's what? Yeah. One x value for every y value. How does it pass that? It does not, right? So that does not pass that test. And this is the horizontal line test. So this right here tells me that it is not 1 to 1. Okay. And this is important for when we are going to graph our inverse curves in our inverse graphs, and also when we are evaluating our trig functions. Okay, good deal. So to be 1 to 1, it will have to pass being a function, which it does, and then it has to pass the horizontal line test. So don't forget that this is the horizontal line test. Okay. Can I make it 1 to 1? Can I make sine a 1 to 1 function?
Yes.
Okay. How can I make it a 1 to 1 function here? Restrict the domain. So what could I restrict the domain to? So that I don't have a repeating x and y values. So can I restrict the domains? So where could I restrict the domains, Justin? Pi. Okay. So what do you mean by pi? So 0 to pi? Okay. So let's restrict the domain from 0 to pi. Is that true? Is that going to be 1 to 1 there? No, it's not. Okay. Why is it not 1 to 1? Because that top peak, right? The top peak is going to touch twice. So that's not going to be true there. So I can't restrict it from 0 to pi, even though I would love to. Yeah. Oh, this is going to be bad. I'm sorry. Now I'm going to erase all my beautiful lines. Okay. So do you see another spot where you could possibly restrict the domain? Perfecto. So negative pi over 2 to a positive pi over 2. So if I were now that means I'm just looking at this part of my graph, right? So I'm just looking at that part of my graph. Is there anything that repeats? So I have no repeating y values there. So if I restrict the domain, I can restrict the domain to negative pi over 2 to a positive pi over 2. Does that change my range any? Is my range still the same? Because remember what your range of sine is. It doesn't change it, right? Good deal. So the range of a sine function or a normal sine function, remember, is -1 to a +1. So my range doesn't change here. So my range is still -1 to 1. Okay. All right. So what quadrant? So if I restrict the domain to negative pi over 2 to positive pi over 2, so think back to your unit circle. So where did I restrict the domain to? So what quadrant, if you wanted to say that, so what quadrant would this from 0 to pi over 2, what quadrant would that be? 1. So this would be my quadrant 1, right? And then what if I went backwards? So from negative pi over 2 to 0, what quadrant would that be? So that would be my quadrant 4, yeah? Good deal. So sine, I'm going to restrict the domain to values that are from in quadrant 4 and quadrant 1. So that also means, remember, I don't use quadrant 4. I use quadrant 4 as negative values, right? So I don't use them as the positive large values. Good? Okay. So let's write that over here. So inverse, so what I'm talking about here. So our inverse sine, okay, so inverse sine, so inverse sine here is going to fall in quadrant 1 and quadrant 4. So we're going to restrict the domain to values, well, let's go back. Let's talk about something. Let's do number 5 before we define this real quick, because it's going to be different. Okay, so now let's use that information to look at number 5. So I restrict the domain to negative pi over 2 to pi over 2, okay? And I then still have a range of negative 1 to 1. So now let's look at number 5 and try to evaluate this. So if I wanted to find, so this is another way to rewrite sine of theta equals 1/2 is the same thing as what? Inverse sine. Remember, we have talked about this, right? So inverse sine, because we use our calculator. We didn't talk about it using our unit circle though. So inverse sine of a 1/2. Okay, so remember that's our inverse notation. All right, so let's evaluate A now. So inverse sine of 1/2 now that I know this, I've restricted my domain from negative pi over 2 to pi over 2. So now what is my value here? So which one of those falls inside that domain, negative pi over 2 to pi over 2? So inverse sine of a positive 1/2. So a positive 1/2, right? So what is that going to be? What is my theta going to be equal to? 30, which is, and remember we like to use our radian measures, so that's what? Pi over 6, perfecto. So this is pi over 6. So this is, remember, this is another way to say what theta value, so sine of what theta value is equal to a 1/2. Okay. All right, what about B? So inverse sine of a negative square roots of 2 over a 2. So where is sine of theta, right? So where is sine of theta going to be equal to negative square roots of 2 over a 2? Okay, so 5 pi over 4, but instead of saying 5 pi over 4, I'm going to say what? So I'm going to give so think about this little graph right here. So think about this graph. So instead of saying 5 pi over 4, I'm going to say the negative version that's associated with 5 pi over 4. So the negative value that would be that equivalent would be what, Justin? So not negative 3 pi, so it'll be just a negative pi over 4. Good deal. So negative pi over 4. Good? All right, what about inverse sine of 0? So where is sine of theta going to be equal to a 0? And that's going to be what? 0, thank you. Okay. So now let's talk about, let me go back to my little formal definition over here. So now my inverse sine, so remember your inverse, your domains and your ranges switch, okay? So my inverse sine here is going to be y equals inverse sine of x. So my domain for an inverse sine function is going to be the range, what I said, of my regular sine function. So what's the range of your regular sine function? -1 to a +1, right? So the domain here of an inverse sine function is going to be -1 to 1. And then my range is going to be the domain of my regular function, yes? So they're going to flip-flop. So what is the range of inverse sine then going to be? So it's going to look a little crazy. So it's going to be what, -π/2, because I restricted it, right? I restricted it to make it a 1-to-1 function. Good deal? Does that make sense? Okay, so now let's think about cosine in that same light. So let's look at cosine. Can you use the same interval to restrict the domain of cosine? So let's test it out. Can I do that? So take a second, if y'all haven't done this part, and do this part for me. So try to answer cosine for me. Okay, so let's draw this on the graph. So from -π/2 to π/2. So can I restrict cosine to -π/2 to π/2? No, it's not 1-to-1 that way. Is there another way that I could restrict cosine? Okay, so what do you think? So 0 to what? Pi, perfect. Okay, and there creates a 1-to-1 function. So I don't have any repeating, right? I don't have any repeating y values right there. Okay, so we're going to restrict the domain for cosine to be an 1-to-1 function from 0 to pi. So what's the range of your regular cosine? And it's still -1. It didn't change it, right? So how I restricted that domain doesn't change my outputs, right? So for regular cosine, it does not change any. Are you okay with that? Okay, so now let's evaluate these. Okay, so where is cosine, inverse cosine, a 1/2? So where is inverse cosine, a 1/2? So here's my 1/2, right? So if I drew it here, where is inverse cosine going to be equal to a 1/2? So what theta value is cosine of that theta going to be equal to 1/2? So this is just another way to think about it, yeah? What value is that? So where is cosine? So, okay, let's go back. Let's go back and think about this then. So what quadrant is this in? So what values am I looking for cosine here? So cosine of theta goes from 0 to pi. I've restricted the domain. So what quadrant am I in? So quadrant 1 and quadrant what? 2. Perfecto. Okay. So those are the only outputs that I'm going to do when I'm looking at inverse cosine. So cosine of theta is equal to a 1/2 where? Do we need to practice our unit circle a little bit better? Pi/3, perfecto. So pi/3. All right, so where is inverse cosine a negative square roots of 2 over a 2? So where is cosine of theta going to be equal to a negative square root of 2 over a 2? So 3 pi over a 4, yeah? Okay. And then where is inverse cosine going to be equal to a 0? So where is cosine of theta equal to 0? And that is where? At what value? So where is cosine of theta equal to 0? So it's going to be what? Pi/2. Perfecto. Oh my, that train has got us twice today. Okay, so let's talk about cosine. So inverse cosine, okay, what quadrants am I going to restrict it to? So I'm going to look at what? Quadrant 1 and quadrant what? 2. Okay, so that means my domain of inverse cosine, what is my domain going to be for inverse cosine? So it's going to be the range of my regular cosine, right? So they're opposites. So what's the domain of inverse cosine? It's going to be what? -1 to 1. But my range, so my output of inverse cosine is going to be my domain of what I restricted that domain to, right? So I restricted that domain from 0 to what? Pi. Perfecto. So my range here is going to say 0 to pi. So that means my output, right? My theta values are going to lie in quadrant 1 and quadrant 2. That's what I'm going to look at for my unit circle. Okay. All right, so let's now look at tangent. So where can I restrict the domain for tangent to be 1 to 1? So is it going to be similar to sine and cosine? So let's look at this graph. Is it going to be 0 to pi? I mean, it could, right? Technically. Yeah. But might be easier to go which way to it? Because I go from maybe from your asymptote to your asymptote, right? So you have one beautiful graph. So one asymptote to the other. So negative pi over 2 to pi over 2. Think that it, because that's one continuous graph, right? So it's got to be my one continuous kind of picture of my graph. Okay. All right, so if we restrict the domain for tangent, very similar to sine, but instead, what happens at negative pi over 2 to pi over 2? Would I put a bracket around negative pi over 2 to pi over 2? Bracket? Would I put a bracket? Why? Perfecto, so I'm going to put a what around it? Parentheses, so I'm going to put a parentheses from negative pi over 2 to positive pi over 2. Perfecto. Now, what is the range for your tangent? So this one's a little different because what's the range of tangent? It's not 1 to 1, -1 to 1 anymore. It's what? It's all real numbers, right? Okay, so now that means for my inverse tangent function, I can put all kinds of values inside to evaluate. Okay, so we're still restricting tangent to what two quadrants? So inverse tangent will be quadrant 1 and quadrant what? 4. Good deal. Okay, so inverse tangent of square roots of 3, so what is that? So where is tangent going to be equal to just square roots of 3? Remember what tangent is equal to. So let's think back. Tangent is equal to y over what? X. So where is tangent going to be equal to just square roots of 3? So it would be where the y value is square root of 3 over a 2, just to help you out a little bit, right? So where is tangent? So I would need to have square roots of 3 over a 2 over a 1/2 to just be left with square roots of 3, right? Okay. So where is tangent going to be a positive square roots of 3 then? So what value?
6.
Over 6. Okay. Where is inverse tangent then going to be equal to a -1? So it's where the x and the y values are going to be what? Are y'all sure inverse tangent of square roots of 3 is pi over 6? Does everybody agree with that? Remember, tangent is what over what? Is y over x, right? Y'all agree with pi over 6, or y'all just going with the... Is it pi over 3, or is it pi over 6? Okay, are you sure? Why? What's the y value of pi over 3? Square root of 3 over 2, yeah? And then, so remember, it's flip-flop. We're not looking at x. It's not the ratio of x over y, right? It's the ratio of y over x. Okay. All right, so inverse tangent of -1, so that's going to be a negative pi over 4. Okay. So that would mean remember, I have the same to the x and the y value are identical. Okay, so we could also graph these, because remember what we do with our inverse functions, we just switch our what and what? We're just switching our x and our y values, right? So we'll just switch those x and y values. So we could definitely graph these as well. Okay? All right, so let's kind of recap a little bit of our inverse trig functions, because we will talk about graphing them as well. But let's just kind of recap a little bit. So for inverse functions, remember you switch your, what did I just say? Inverse, you switch, so switch x and y, so we're switching our range and our domain, right? Okay. All right, so inverse sine, you also could see this written as arc sine. So you may see this as well, like this, arc sine. When you take calculus or Cal 2, you'll see arc sine written a little bit more because it gets a little less confusing than that little inverse notation. So that is just another way that you could see that written, okay? So remember what our x value is. So our x value is the ratio, yeah? And the y value here is the radian measure, yes? So the angle measure, and we usually always put the output in radians, okay? Good deal? All right, so the domain of your sine function, your inverse sine function, I'm sorry, is going to be -1 to 1. Your range of your inverse sine function is going to be negative pi over 2 to positive pi over 2. Okay. So if I were to graph this, then on the x-axis, what values would be on the x-axis? So I would go from -1 to a +1 over here. Oh, my thing is going crazy. We're having some technical difficulties here. All the technical difficulties. So if I restricted my domain for my x-axis from -1 to 1, what are then going to be my output? So on the y-axis then for sine, I would go from negative pi over 2 to positive pi over 2. Yes? So here, my graph is this is gonna be just my peak of my inverse sine function, okay? So all I did is switch the x and the y values. Yeah? You feel okay about that? All right, so look at cosine. So inverse cosine, so the other way that you could see inverse cosine is arc cosine. So same thing is inside your inverse cosine function, you'll have a ratio And your output of your inverse cosine function is going to be your angle measurement, which is your radian value. Okay? So the domain of your inverse cosine is going to be from what to what? -1 to 1. So we can't have anything that's outside of that value because we'll look at our normal cosine curve, right? And then our range of output for inverse cosine is going to be from 0 to pi because I restricted my domain. So what two quadrants is from 0 to pi? 1 and 2. Good deal. So if I graphed that on the x-axis, I would have -1 to 1. And then on the y-axis, I would go from, my range would go from 0 to pi. Yeah? Good? All right. And then what about inverse tangent? So inverse tangent, same thing, but I'm restricting my range here. My range here is going to be a little bit different. And I'm going to have my asymptotes at -pi/2 and pi/2 if I were to graph my inverse tangent function. So inverse tangent is going to go, my domain is all real values, so it's going to be continuous that way. All real values for my domain for my inverse tangent function. And then my range is going to be my outputs. It's going to go from -pi/2 to +pi/2. So you can also see your inverse function is also labeled arctangent. So arctangent is just another way. So you'll see arc just means inverse. Okay? Does that make sense? Okay? Do you have questions about that? Sorry, I was having some technical difficulties.